Okay, so today we are going to start with the organic chemistry. So, organic chemistry is actually based on carbon or carbon containing compounds. When we talk about carbon, we know its atomic number is 6, which means 6 protons and 6 electrons in it. Mass number is 12 and its relative atomic mass is also 12. When we talk about carbon atom, it forms 4 covalent bonds. Okay. Carbon is unique as it can bond with itself, forming a variety of structure, which includes, so that is the very important thing about carbon, that carbon is very unique in this regard, that this property, only carbon atom has this property. Carbon as an element, no other elements has this property, that it can bond with itself to form a very long, very huge, very giant structures. Like, for example, if you want to look out oxygen, you will find that is the oxygen or either that is the oxygen. You can't find more than 3 atoms bonded of oxygen that are bonded together. But in carbon, there is a possibility that 100, 200, 300 carbons can be bonded with each other. And they can bond with so many different ways because each carbon can make 4 bonds. Now, if you see the first type, they can bond with each other. We call it straight chain or unbranched chain. Okay. So how did you identify that it is unbranched? This thing, that each carbon bonds with maximum of how many carbons? With the maximum of 2 carbons only. So if each carbon is bonded to maximum of 2 carbons, then it's a what structure? Unbranched structure. Okay, now look over here. If I'm drawing this structure, so can anyone tell me whether it's a branched structure or unbranched structure? Unbranched? Royal says unbranched. What did you think? Unbranched. Why? How? Show me any carbon which is bonded to more than 2 carbons. Can you able to find any carbon in this chain which is bonded to more than 2 carbons? Is there any carbon like this? Yes, everyone. Yes, Kubra, Laiba. Oh, sorry. Khatija, Mustafa, and Mustafa. See, is there any carbon which is bonded to more than 2 carbons?
No, sir.
No?
No, sir.
If you see this carbon and this carbon, these two are bonded to only 1 carbon. And any other carbon which you see in the whole chain has bonded to how many carbons? 2 carbons, not more than 2, right? So it means it's a unbranched structure like this. What I just did, I just twisted. So whether it is in the twisted form or in the jumbled form or whether it's a straight, you have to look at the bonds to identify whether it's a branched structure or unbranched structure. Is this understandable?
Yes, sir.
Then we have a branch chain. How can you identify that it is the branch chain? It's very simple. That at least 1 carbon atom which is bonded to minimum 3 carbon atoms. There must be, if there is any carbon atom in the whole structure which is bonded to minimum of 3 carbons, then it means that's a branch chain. That's a branch chain. Is this clear? Okay. Now, see, if you look at this, oops. If you look at this one, this carbon is bonded to how many carbons?
3 carbon.
This carbon is bonded to
3
carbons. This carbon is bonded to 3. This carbon is bonded to 4. So if it's the chain, the structure has a minimum, a carbon which is bonded minimum to 3 carbons. So it means it's a branch chain structure. Is this clear? Okay, complete this quickly. Then we will proceed further.
सर अगर 4 कार्बन से बॉन्डेड होगा तो फिर क्या होगा?
Obviously, it's a branch. I have written that a carbon which is to minimum 3 carbon atoms. So see, it's the minimum is 3. So if it's bond with more than 3, then obviously it's a branched.
Okay, sir.
Is everybody done till here?
Yes, sir.
Are you guys done? Yes. Yes, everybody completed till here? Okay, there is a third way as well, and that is, close ring or close chain structures like this. If you see what happens over here, that the first carbon and the last carbon, they just two got bonded to each other, and as a result, giving us a close chain structure like this. So, see, this is the third way that the carbon atoms can bond in a different manner. And beside this, as atoms can make multiple bonds with itself, which also make them to show different structures having the same number of carbon atoms. Like if you see, there are three different structures in your, and all of these have a same number of carbon atoms, but due to the bonds, see, the first one have all single covalent bonds, the second one has a double bond, and the third one has a triple bond. Okay. So complete till here.
सर हेलो
Yes.
सर कार्बन अपने साथ सिर्फ 4 एटम बॉन्ड कर सकते हैं ना
Yeah, carbon can bond make 4 single covalent bonds.
तो सर वहाँ पे 1 2 3 4 बॉन्ड है और जो लास्ट वाला कार्बन है वो देखें पैटर्न
On which carbon you are talking about?
सर नीचे नीचे नीचे
This one?
ये कार्बन कार्बन जी
But
जी जी जी
this carbon has 3 bonds over here and 1 over here. So still it's making 4 bonds, right?
ओके सर
In the same way, this carbon also makes 4 bonds because 3 bonds are over here and 1 is over here. So it depends whether 4 single bonds like this, or 2 double bonds, or a 1 double bond and 2 single bonds, or a triple bond and a 1 single bond. So see, these are all will be the possibilities of the 4 bonds. Is it clear?
यस सर थैंक यू
Completed? Yes. Okay. Yes, everyone completed till here. Okay. Now, the other atoms that bond with the carbon at different positions also able to make them to show multiple structures like this. See, if the chlorine is over here and the chlorine is over here, make them two different compounds due to the position of the chlorine. Okay. So all of the above are the reasons due to which carbon can make different variety of compounds. Okay. So the interesting thing, that if we just count the compounds made by carbon only, and then we count the compounds which are made by all of the elements, carbon has still more compounds than all of the elements and their compounds in the periodic table. So carbon makes so a large number of compounds. So in organic compounds, the basic skeleton or the basic structure is of carbon, which is bonded to each other, and then with the hydrogen, that these kind of compounds are called hydrocarbons. And the one in which the organic compounds, there are other elements like halogens, oxygen, nitrogen, sulfur, etc. are present along with the carbon and hydrogen. We call them derivatives of hydrocarbon. Till here, is this understandable to all of you? Okay, complete this. Are you guys done?
Done, sir.
Okay. Yes, Khatija, Laiba, and Saad.
Yes, sir, done.
Yes, Rohit. Manas. Hmm?
सर
Hmm.
सर ऑर्गेनिक को कंप्लीट करते हुए कितना टाइम लगेगा हमें?
It depends on you guys. Okay, we'll keep few extra classes so we are able to end it by the first week of April only. If you guys are ready to take few online classes as well.
यस सर श्योर.
Okay. Now we have a definition of organic chemistry that you can define it as a study of hydrocarbons and their derivatives. Then you must remember these number of bonds which is made by each element. Like carbon can form 4 covalent bonds, nitrogen can form 3, oxygen can form 2, and halogens and hydrogen can form 1 covalent bond each. So you have to remember these number of bonds. Yes, done. Okay.
Yes, sir.
Okay, now think of this compound. It's a formula C2H6O. Now, see, it's just a molecular formula, but if you try to draw the structure, you can draw the structure of this like this as well. And its structure can be written or drawn like this as well, because it is just telling you that how many atoms are there. And if we keep in mind the number of bonds that is made by carbon, that is made by oxygen, and that is made by hydrogen, and on the basis of that, if we try to draw the structure, so we can get two possible structures, right? And both are correct. So see, this is one another reason that having a same formula, but ending up at a different structures makes the more number of compounds in organic chemistry. Is this understandable?
सर
Yes.
सर ये अल्कोहल का स्ट्रक्चर.
This one, the right one is an alcohol, but the left one is not an alcohol. But see, both have a same molecular formula, isn't it?
Yep.
Sir,
Yes.
can you not write OH together? without placing the bond between them?
Sorry,
Can we not write OH together without placing a bond between them in second structure?
here.
Yes.
Okay, you can you can do this or you can do this, but the thing is that when the examiner asks you to write the displayed formula, if that term is mentioned, and if you did this whole thing, but here you did this, then you will be marked wrong. If the
Okay,
examiner
sir.
has mentioned you to draw the displayed formula, so you have to show each and every single bond in the structure.
Okay, sir.
Okay, just complete this, then we will discuss further. Do it quickly. Left side. Done? Yes, sir.
Yes, sir.
Okay. Now we have few terms to understand. Functional group. It can be an atom or a group of atom, which is the reactive part of the molecule. And the same type of compound have a same functional group. So see, this is the functional group. Like if you see over here, this is the different thing in the whole molecule. So that is the functional group. If you see, this part is different in the whole molecule. So this is the functional group. So the group which is actually unique and has and it's the reactive part of the molecule, that is the functional group. So these are the possible functional groups. Okay. Then we have a homologous series. What is basically homologous series? It's a synonym for a group. So any group of a compound which have same general formula, having same functional group and same chemical properties, that group of compound is called a homologous series. And in a homologous series, each next member is differ by CH1 CH2 group. It means that every next member has a one more carbon and two hydrogen, then the next one has a one carbon and two more hydrogen. There is a gradual change in the physical properties in the members of the homologous series, and these are the names of the homologous series, the groups: alkanes, alkenes, alcohols, carboxylic acid, and esters. And these are the 5 homologous series or a group of compounds that we are going to study. In our syllabus further. Okay, complete this. Is everybody done till here?
Yes, sir.
Completed?
Yes, sir.
Yes, Malahil. Yes, done. Okay. Now make this table quickly in the new page with these 4 columns.
सर
Yes,
सर ये PDF शेयर कर दिएगा सर.
yes. Okay. Now, the next thing that you have to remember these. That is very important. Okay. So you guys have to remember this. The first homologous series is alkane and its general formula is CnH2n plus 2. And their general name is also called alkane. And there is a no functional group in them. Then we have alkene, their general formula is CnH2n. Their general name is alkene and they have a carbon-carbon double bond as their functional group. Then we have alcohols, their general formula is CnH2n plus 2O or CnH2n plus 1OH. Their general name is alkanol as the functional group is OH present in them. Then we have a carboxylic acid. They have a 2 general formulas. One is CnH2nO2 and the other one is CnH2n plus 1 COOH. In this case, we always keep one carbon atom less than the total carbon atoms. That's what we will discuss when we will writing the structures. Their general name is alkanoic acid and it can be written like this: a carbon with a double bond O, and that same carbon is single bonded to O, and that O is bonded to H, or in the closed form COOH. Then we have the ester. Its general formula is same as of carboxylic acid, which is CnH2nO. The general name is alkyl alkanoate, and the only difference is that in carboxylic acid, where there is a C double bond O, then OH, that H is displaced by the carbon chain, then it would become an ester. Okay. So this is the last thing that you guys have to do. As you guys finish it, you can leave. And in the next class, we will continue from here onwards. Okay. Yes, so from here we will continue in our next class.